Assalamu alaikum everyone. This video is a revised excerpt of a past upload on unit vectors. Given a particle with its initial position and velocity vector expressed in terms of the I, J, and K unit vectors, we are to determine its position vector after a given time. So just stick around, watch and learn. The question is, a particle P is moving with a constant velocity of 8.0 meters per second in a direction 4.0 I minus j minus 4.0 k. At time equals 0, P is at a point whose position vector is 5.0 I plus 2.0 j minus 6.0 k. Find the position vector of a particle P at time equals 5.0 second. Alright, so in this problem, we're given the velocity vector with its magnitude of 8.0 meters per second and its direction expressed in I, J, and K units. That is, its direction is 4.0 I minus J minus 4.0 K. At time equals 0, the position vector is given as 5.0 I plus 2.0 J minus 6.0 K. And we are required to find the position vector of the particle at time equals 5.0 seconds. And our computation starts with getting the unit vector, that is, dividing the vector's direction by the vector's magnitude. The velocity vector can then be expressed in terms of the unit vector, all right, multiplied by 8.0 meters per second. All right, we can then express the displacement vector, okay, at time equals 5.0 seconds, all right, as the velocity vector multiplied by the time 5.0 seconds. And subtracting the initial displacement from the final displacement, we can find the position vector at time equals 5.0 seconds. And moving on to our computations, the unit vector, right, is equal to, all right, 4.0 I minus j minus 4.0 k divided by the magnitude of this vector, that is, using the Pythagorean formula, square root of 4.0 squared plus negative 1.0 squared plus negative 4.0 squared. Alright, so our unit vector uh, is expressed as 4.0i minus j minus 4.0k divided by the magnitude of the given vector, and that is equal to uh, square root of 4.0 squared. This actually is the x component of the vector, plus negative 1.0 squared, that's the y component, and negative 4.0 squared, that is the z component, right? So when we do our math in simplifying our denominator, we actually get 5.7, right? So our unit vector now can be expressed as 4.0i minus j minus 4.0k divided by 5.7. And when this unit vector is multiplied by 8.0 meters per second, then we get the velocity vector, all right? Which when simplified, that will be equal to 5.6i minus 1.4j minus 5.6k. Let it be understood that the velocity vector is constant, all right? It has a constant magnitude and a constant direction. The displacement of the particle in time 5.0 seconds, therefore, is equal to the velocity vector v multiplied by 5.0 seconds. Or, that is quantity 5.6i minus 1.4j minus 5.6k multiplied by 5.0 seconds. So we get the displacement. In this case, this is the final displacement equal to 28i minus 7.0j minus 28k. And finally, we can now find the position vector at time equals 5.0 seconds, right? That is simply the difference between the final displacement minus the given initial displacement. Or, all right, our final displacement, 28i minus 7.0j minus 28k, minus the initial displacement that is given equal to quantity 5.0i plus 2.0j minus 6.0k, right? So when you do our math, we get the position vector equal to 23i minus 9.0j minus 22k. This is the final answer to the question. So that's about all. Till the next episode. Mabuhay. Masya Allah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.